Hi everyone, welcome to Activeman channel. Today we're gonna have a special guest. This is the first of series Chat with Activeman, and here is my friend Ankur.
So my name is Ankur Daharwal, and I'm a blockchain engineer, blockchain specialist, been into the space for around 5 years. And I'm totally excited to be on your channel today.
Okay.
So I did my computer science engineering in 2011, and I kind of worked on various projects into telecom and even other industries, but these were all kind of software projects into conventional software development. Blockchain kind of happened as happenstance, I would say, just by chance. Since I was working with IBM Technologies and they were setting up a new team to be focused on blockchain technology.
Wow.
So that team was actually the Blockchain Garage, and I was part of that team and kind of leading certain projects in terms of delivering blockchain POCs and pilot projects for different clients of IBM. That was pretty much my journey, how I began. And after that, it's been a roller coaster ride, working on from one project to another and exploring all the potential of blockchain that's out there today.
Okay, cool. Can you explain some idea as I'm 5 years old? So can you tell me what is blockchain and what happened with blockchain right now?
Sure, that's very challenging, Young. So if you're 5 years old, blockchain technology might be a bit more complex to explain, but I'm going to give it a try. So you're 5 years old. I think you understand what blocks are. So you play with blocks. So blockchain is a chain of blocks. Every block has transactions, and these transactions are validated by agreement. So if everyone in the room agrees that this transaction is valid, it goes into the block. And once the block is full, a new block is created. And that's how the blockchain is formed.
Okay, right. I think Mike is gonna understand this. I will try to explain to me one day.
The history of blockchain definitely starts with the Bitcoin white paper and the launch of the Bitcoin network itself, which was done by an anonymous party, still unknown. Could be an individual or a group of individuals, but represented by the name of Satoshi Nakamoto. So 2009 is when was the inception of the Bitcoin network, and that was the first visual into what does decentralization look like. And the fun part is that it was decentralization of the most interesting asset that anyone can own. It's money. So decentralization of money is where it began, and that was the first, what we consider the first generation blockchain. And soon after, like in 2013, the development of Ethereum was kind of on the final stages. And then 2014-15 is when we saw Ethereum come into play. And Ethereum is considered as the second generation blockchain that supports extendability in terms of not just decentralization of money or value, but also adding logic into your decentralization in the form of smart contracts. So smart contracts was introduced when Ethereum came into existence. So all thanks to like Vitalik Buterin and all the team around the Ethereum Foundation that had kind of supported the whole development process for Ethereum. And today itself is also considered as the most widely used network, and we would find a lot of assets kind of moving around in the Ethereum network. Now, ever since Ethereum kind of was launched, everyone was targeting towards solving the problems of Ethereum. And what would be the problems of Ethereum is basically what we call the blockchain trilemma, which is kind of having a balance between decentralization, security, and scalability. So it's as if you can have only two, not the third. So you cannot always have all three. But what you can have is a balance in terms of what's required most in your solution in your blockchain network. That's more essential to you. If security is more essential, you would have to compromise in either of scalability or in terms of decentralization. So yeah, it's a choice to make, and that's what the next generation blockchains kind of looked into hacking So I would say 2.5, generation 2.5 is where, the blockchain trilemma was being hacked. Generation 3 is where we are at right now. So the third generation blockchains are focusing on solving interoperability to be able to have inbuilt cross-chain functionality within the blockchain network that can talk to all other blockchains out there. And that's something that we can see now in notable projects like Avalanche, like Polygon. There are many other projects that are supporting this. The first, I would say, to kind of come up with this idea were Cosmos and EOS. This could be back in, I think, 2018. And ever since, we're now kind of evolving towards the stage where all the blockchains are talking to each other and transferring assets as well. So your existence on one network would also kind of represent your existence on any other network, since now we are all getting connected.
All right, cool. And the next one is about how you choose blockchain solution, like a lot of solution right now. Everyone say a good thing about them. How do you choose us?
Right, that's another good question. So selecting your blockchain platform requires a study or analysis on various aspects. So broadly, I would classify that into the business criteria and the technical criteria. So on the business criteria, I think what's important is when was the project launched? Who's behind the project? What are the foundations supporting the project? Then the market cap of the native token, whether it has some notable projects already launched, whether it supports a huge ecosystem of different products. That's also a good, option based on which you can make your evaluation. So total value locked is also another criteria that we use in terms of understanding how much value does a blockchain, has logged into their system right now. And that's being kind of reserved on the platform. It's being utilized on the platform. Now, next we can move on to a bit more technical aspects of things. So in our evaluation, we would consider the consensus mechanism, which is kind of the heart of a blockchain that defines how transactions will be validated and what is required from the participants of the network to validate a transaction. So that would be one. The other could be whether it supports cross-chain functionality or interoperability. If your project has the need to kind of have different chains for different operations, so you would have to kind of include side chains. So does the blockchain support side chains? Could be one of the criteria as well. If you're programming your smart contracts on Solidity, so what's essential for you is to make sure that your blockchain has EVM compatibility, which is the Ethereum virtual machine. Once you have EVM compatibility, then you have to make sure that it has the right compiler version support for your smart contract. So these would be, I guess, some of the parameters based on which I would decide or evaluate my choice of blockchain.
Ask me why it's happened, but I don't know why, so I'm gonna ask you, Ankur. Here's the question. Sometimes the transaction come from it takes 1 hour, but somehow it takes 5 minutes. What happened? Can you tell me?
That's an interesting question, and one of the most fundamental concepts of how a blockchain transaction is confirmed on a blockchain network. So when a transaction is broadcasted to a network, let's take, for example, here, the Ethereum network, then the transaction sits in a pool, which we call the transaction pool, that is waiting there for validators to pick up and confirm the transaction. Now, these validators, they have kind of their own criteria. It's a democratic solution where people can define the minimum amount of fee that they would require to pick up a transaction, or that's going to be more kind of suited to their choice of validating those transactions. So it's all depending on the amount of gas fee that one person or the other is willing to pay in terms of speeding up their transaction on the network. Because higher the fee you're paying, it's more likely that a validator will be picking up that transaction from the pool. So that's basically a very basic concept that uh, helps you to speed up transactions on the network. By paying a bit more fee, it's a bit more incentive for miners and validators to confirm your transaction before other transactions.
All right, and another related question, fee and gas price, right? What is different between them?
Sure. So we have transaction fees for every transaction, and those fees are collected by miners and the validators. So that's the fees that we are paying to the network in terms of confirming our transaction. But then what it costs in terms of executing the transaction also involves all the gas consumed for executing the different operations in the smart contract. So if you're calling a smart contract function, then it executes different operations. All of these operations are well defined by a definitive, opcode, and it has a precise amount of gas that it would cost to execute that operation. So it's kind of easy to calculate and not so easy maybe in complex contracts, the full gas that's required to execute a transaction. So that I believe would explain what a gas fee is and what the gas price and cost is.
And yep, this is the interesting question about the career path. It is difficult to get in the blockchain industry, and can you tell me how did you get to the first job in blockchain?
Right, that's a very good question, Young. So there are different career paths that one can take in blockchain industry, and definitely depends on your experience and the kind of background that you're coming from. So entry level engineers maybe would get into something like a dApp developer, someone focused into building decentralized applications. Someone a bit more senior to them, who's kind of more well versed with the back end engineering, could get into blockchain protocol engineer type roles, where they're kind of building blockchain protocols from scratch with the new consensus engine and all the underlying components of a blockchain platform. That's another role. So we discussed right now dApp developers and blockchain protocol engineers. Moving on, there are some more roles which are not so technical, but also are very relevant in the blockchain industry. So we have blockchain research analysts who kind of take, who conduct research in terms of the latest trends, the latest technologies, the latest protocols, the most adoptive or explosive, trends in blockchain industry. So that's also one of the roles that they can get into. They're definitely content writers, and then there are also other non-technical roles. One more I would suggest would be tokenomic strategist, a person who is kind of well versed with the economics of underlying like tokenized assets, and that's another role I would say in the blockchain industry that's very relevant in terms of how you can get into the blockchain industry.
Okay.
But if we stick to a bit more technical aspect of it, I would say, yeah, blockchain technology today is just like how the internet was in 1994 and 95. Everyone wants to build a website in 94. And now everyone wants to build a blockchain application, and they want to deploy their own NFT. So to me, it's kind of a mix and match of how how you can get into a project that's requiring somebody of your skill sets, and the skill set could be limited to traditional software engineering. So there are teams now that are focused on kind of training their new employees, their new engineers on board, and getting them up to speed on blockchain technology. So those are the teams that entry-level engineers should be kind of looking forward to seeking work opportunity with. The other way would be to be a self-starter, a self-learner, start building your own POCs, try it out, and post it somewhere, and publish it on GitHub, make it open source, start contributing to open source projects. Blockchain protocols, all the platforms are open source. It's a community thing. So it's all driven by the power of the developer community. It's not driven by a centralized organization. So we are all part of it. We all have the chance and the opportunity to take part in it.
Okay, cool. Do you have any website or web portal to get to find a job in this industry?
Yeah, I did come across many, but there's one that really always, I tend to go towards it most of the time. So it's called cryptojobslist.com. Perhaps you can add that to the caption, and people can get a reference. It's one of the, I would say, it has the best blockchain jobs out there, and it's all kind of relevant to people who are getting into the blockchain space. And yeah, it's a recommendation, I guess, from my point.
Okay, want to know more about technical, so I had a list of technical questions for you, Ankur. Here, the first one.
Sure.
Why we need to have a big number with the Web3? And some library, they have that wrapper. Why do
Right. Okay. So Web3 is supporting like different languages. It could be JavaScript or Python. But when it comes to SafeMath library, that's purely on Solidity. But okay, yeah, that's a good question, Young. Let's dive a bit into the mathematical concepts of smart contracts. So natively, Solidity does not support fixed point decimal numbers. It supports integers instead. So whatever variables we use in Solidity, there are either signed or an unsigned integer that could be of different byte value. So smart contracts and blockchain in general, they're used for storing value and exchanging value. So precision is something that's very important or integral to the design of blockchains, and that needs to be handled in the code itself. So for this purpose, larger signed and unsigned numbers are used instead of decimal or fixed point numbers. So if you take Bitcoin, for example, it has a precision of 8 points or 8 decimals, and a single unit is represented as what we can call Satoshi. So that's the smallest unit of a Bitcoin, which is to the order of 8. And similarly, so Ethereum coming later in the evolutionary trajectory of blockchains, it kind of supported a larger or wider range of integers. So this is to the order of 18 decimal points. And that's why we don't have any decimal numbers, but we have 18 digits of Ethereum values that are used within the Solidity code that we use. Now, once this value is kind of extracted using a third-party library, there could be Web3 or Ethers.js. In your native language, like it has to be converted from what's being sent from Solidity in a big number format and imported back into a big number format, which is why we need big numbers to support values on Web3. And I believe that would answer the question on why. Yeah.
And the second one, like, what is SafeMath library using for? Why do we need that? I think that limitation on Solidity, right?
SafeMath is a library that was used before 0.8. So in version 0.8, it's kind of built into the compiler and doesn't need to be kind of imported or used by smart contracts. So the purpose of SafeMath is to identify any overflows or underflows in mathematical operations within Solidity.
Okay.
So when we're using these wide range of numbers, which are either unsigned or signed integers, there's a possibility of an overflow or an underflow when we're kind of multiplying, dividing, adding, subtracting, all the mathematical operations. So it's kind of essential for us to take that case into account. And what SafeMath does is adds some required statements to ensure that if there is an overflow or an underflow, it throws a revert instead of executing the transaction.
All right.
So it's a fail-safe method or a fail-safe library for mathematical operations. And good thing is like it's going to be inbuilt. So in 0.8 onwards, we don't need to worry about SafeMath.
Okay, cool. This is the question about NFT game. Let's say I'm building an NFT game which allow end user to buy an ERC20 token for an item, like the drop NFT. You have the website, have UI. Someone say, claim this NFT item. So they will open the wallet and the authentication, then they process. After that, they get the item. So can you tell me the solution about how you do this one? Yep.
Sure, that's a good question, and it's a very hot topic these days. So NFT games is something that's being widely kind of used, and it's coined as a term called GameFi, where it's merging DeFi and the game industry itself. So to answer your question, in terms of NFT drops or conducting NFT purchases, and if you want to utilize an ERC20 to do this, so what you need essentially first is the ERC20 contract that supports the purchase of these tokens. Then we need the ERC721, which is the NFT contract itself. So a contract that helps us create these NFT assets is required. And then there's another contract that would accept these ERC20 and be responsible for issuance of the 721 to the wallet address that had sent over the ERC20.
Okay.
And then definitely a registry in terms of a mapping is required to make sure that the assets provided or issued have been kind of registered into the mapping as well for kind of reference in terms of the smart contract having knowledge on who is owning the NFT.
Okay, cool. Yep. It's clear now. Like you need to have 3 smart contracts, right?
Yeah.
All right.
Yeah.
Okay, cool. How to build an API for smart contracts? Could you give us an example with Node.js or Golang or any languages you want?
Sure. Yeah. So this is something that I touched based on very briefly, that blockchain nodes have built-in client endpoints to interact with, and they're in the form of JSON RPC or WebSockets that you can connect to, establish a connection with a Web3 provider. So Web3 library supports the connectivity to these blockchain nodes. And another fun fact I would say is it also supports GraphQL. So that's also another point of support in terms of blockchain nodes having the capability to establish an interface with applications. So an EVM compatible blockchain node supports all libraries of Web3 in all the different flavors, as well as Ethers. And let's take JavaScript as a reference here. So Ethers.js and Web3.js are the libraries that can be used. Once a connection is established, then we would use Web3 to instantiate a smart contract object. Now, the smart contract object would require to utilize, the ABI. So the ABI is application binary interface that has all the details of the different functions defined within the contract. Now, once we have an understanding of what the contract definition looks like, then we can start interacting with the different functions using the Web3 instantiated smart contract object. So all of this can be done in Node.js, where we are connecting to Web3, instantiating a smart contract, and then utilizing the Web3 inbuilt functions to interact with the smart contract functions. And now, as a design practice or maybe even a security layer, we can have these into separate APIs that we design in terms of two categories of functions on Solidity that we would kind of high-levelly consider is mutation functions first, and second could be getter functions just to read data from the smart contract. So all of these, once they are kind of created into a new API, we can add another layer of authentication to avoid, to provide a bit more security to our decentralized application in terms of integration using APIs. And then it's totally up to us, and in terms of what type of APIs we want to use. We can use REST, or we can use GraphQL, or any other type of API implementation.
Okay, cool, Ankur. Very detailed for me. And I think that a lot of lesson learned for today. So once again, thank you very much for joining me today. If you guys had any question, please comment below. I will try to get that question to Ankur. Bye bye.
All right. Thank you for having me, John.
Thank you.
And
Bye
good
bye.
luck. All the best. Thank you.